So what is an amp? A quick recap. Metals like copper have electrons that flow freely throughout the material, from atom to atom, even at room temperatures. And as explained in the first video with the marble analogy, when electrons move from atom to atom, they displace other electrons already there, which then push other electrons, and so on and so forth. These properties make metals excellent conductors. There are billions upon billions of electrons in even a single simple copper wire. Now, when creating an electric current, it's useful to be able to measure this current. This is measured in amps or ampere. 1 amp equals 1 coulomb per second. Ampere is the base unit of electric current, or how many electrons flow past a single point every second. 1 coulomb is the unit of electric charge, which is carried by approximately 6.24 times 10 to the power of 18 electrons. That's 6.24 quintillion electrons flowing past a certain point every second. 2 amps is double that number of electrons flowing past every second. 0.5 amps, or 500 milliamperes, is half that number of electrons per second. To put it into perspective, the adapter of my laptop requires an electric current of 1 amp, while the current in a lightning strike can vary from 5,000 to 50,000 amperes, depending on the strength of the storm. See the electricity video playlist for more on amps, voltage, watts, resistance.